of S and R, clock is applied, arrow shows that this is a edge triggered JK flip flop, outputs are standard Q and QR. In circuit diagram, with SR flip flop, the NAND gates are used, clock is also applied through these gates, and the output Q and QR are connected back to the inputs through these AND gates. Q is connected with J and QR is connected with K. So, this equation shows here S becomes J into QR and R becomes K into Q. Means we can note that it differs in the RS flip flop such a way that Q output is connected back to the input of the gate 2, means to the second gate, where the QR output is connected back to the input of the gate G1, means with the J. The JK flip flops can be obtained from the SR flip flop by just ANDing the J and K inputs with Q and QR respectively to obtain the S and R inputs. So, let us look at the truth table. So, earlier three rows are same as previously when both J and K are 0. Here clock is there is a downward arrowhead, means this is a falling edge flip flop. When both J and K are 0, the output is previous state, means what is previous. If present state is Q 1 plus 1, previous state is Q and Q 1 means it is previous than the Q 1 plus 1. So, if K is 1, flip flop is a reset, reset means flip flop is 0, means Q is 0, obviously Q R will be 1. If J is 1, flip flop is in set condition means output is 1, output means basic output Q is 1, Q R is obviously 0. Now, let us look at the last row. If both are 1, the output is toggle. Toggle means it is toggled or reverse the previous state. It toggles means it changes its positions from the previous state. Now, let us look at this diagram. Now, first the J and K are the inputs, clock is the clock. So, here rising edge diagram is shown for rising edge. If clock is high, means at the point where clock is high, let us see first K is 0 and J is 1. J 1 means flip flop has set conditions. So, flip flop is set means its output Q is 1, means Q is changed to 1. Now, let us look at the second rising edge of the clock pulse. At this point, both J and K are 1, both J or K and 1 means toggle condition. Toggle condition means flip flop will toggle, it will change its position. So, it is 1 previously, now it will change to 0. Now, at the third rising edge, at this point both J and K are 1, 1 means flip flop will again toggle, toggle means again it will change its position. Now, it will change its position from 0 to 1. Now, at the fourth point, for the fourth rising edge, K is 1 and J is 0, means this means the flip flop is in clear. Clear means it will come from 1 to 0, means it is in reset condition. Now, at the next point, both J and K 0, both J and K 0 means previous state, means there is no state change in the state, previous state is 0. So, it will remain 0 until next clock pulse, and then the next at the next rising edge J is 1 and K is 0, means flip flop again comes to the set conditions, means it will set means the Q will be 1. So, it will change from 0 to 1, go high, and then the last rising edge both J and K are 0, 0 means there is no change in the state. So, it will remain high. Now, what is the race around condition? For changing a flip flop state, we require a mandatory change in the input signal of the clock, and the mandatory change, mandatory means compulsorily change in the input pulse is called triggering, means a pulse start from value 0 to value 1 for short duration and return again to short duration, means when the pulse goes from 0 to 1, then it is called positive edge, when it go from 1 to 0, it is called negative edge. Means we may have the new state of output, while the input pulse is still at logic 1, means still in that period only, means the output is input pulse is at logic 1, the flip flop changes its new state, means it changes its state and may cause the inputs to change. This will cause the second output state. So, when such a situation takes place, we cannot connect the output of flip flop to the input of flip flop at the same clock pulse. The problem was come under transition pulse only instead of using pulse for the entire duration by using RC network. Means we can conclude from the last two slides that for the duration, the duration where the TP of the clock pulse means TP means transition period, the output will oscillate back and forth between 0 and 1, means output will change twice in that period. Means at the end of clock pulse the value of q is uncertain, means q is uncertain, means it is not certain. So, this condition is referred as race around condition, when the flip flop will change its state more than once in the period of one clock pulse. So, this is should be avoided to make flip flop more stable. So, for that purpose the flip flop is modified to a new one which is called master slave JK flip flop. So, master slave JK flip flop is the solution of that race around condition, means the race around condition is eliminated in master slave JK flip flop. Now, in master slave JK flip flop racing around condition is or the problem is avoided, but racing around means the problem of toggling more than once during a positive clock pulse, means toggling means changing states more than once during the positive clock pulse. This flip flop requires 2 JK flip flops. 2 JK flip flops are required in this case. One is called master and other is called slave. Means to begin with, master is positive edge triggered. This is a difference between master and slave. The master is a positive edge triggered and the slave is negative edge triggered flip flop. First master respond to the JK. In this case, first the master flip flop responds to the JK inputs and then the slave follows it, means then slave respondents. That is why the first one is called master, the second one is called slave, because slave follows the master flip flop. So, this is the diagram, symbolic diagram of this master slave JK flip flop. In this case, the first condition is the first JK flip flop is here two JK flip flops are used. The first JK flip flop is master flip flop, the second JK flip flop is slave flip flop. So, in this in master JK flip flop inputs are J and K, outputs are Q and Q1, same in case of slave. So, here the output of slave flip flop are connected to the master flip flop with AND gates are used which are not shown in this, means Q bar is connected with J using AND gate, where Q is connected with K using a AND gate. So, clock pulse is applied, the arrow shows that this is a edge triggered flip flop. Clock is given to the second flip flop to the slave flip flop by inverting it. So, NOT gate is used between this clock of first JK flip flop master flip flop and with second slave flip flop. So, in this case same the last condition that toggle same, the other first two conditions are same. In first case J1 K0 means 1, J0 K1 is 0. Now, what is T flip flop? T flip flop is called toggle flip flop. This is this flip flop is made from JK flip flop. In this case the JK flip flop is shown, means in this case only two rows of truth table, first when both 0 and last when both 1, only those two are used, means in this case J and K is same, means same one input, that is called T input, same input is converted to, connected to J and also to K. So, that is clock, means a detector used, that this is just a basic circuits, this is basically a clock. So, in this case T0 means both J and K are 0, in this case there is no change in the state. If T1 means both J and K are 1, means the flip flop is toggle, will toggle its state, means will change its state. Upper arrowhead is shown at the clock, means this is a rising edge T flip flop. So, this is the symbol of T flip flop, circuit symbol Q, QR, QR is inverted shown in symbol. J and K are short circuited, means connected to the same input, that is called T clock. Means in a JK flip flop, if J and K are equal, means both are same, the resulting flip flop is referred as a T flip flop, means it has only one input referred as a T input. When T is high or 1 applying on the clock pulse, the output toggles, means both J and K becomes 1. So, it toggles. When T is low, means when T becomes 0. So, both J and K become 0, means it remains in the previous state, because we know that if both 0, that will rest in the previous state. Now, let us come to the applications of flip flop. Applications means where flip flops are applied. So, what are the applications? So, there are a large number of applications of flip flop. Flip flop has many applications, as we told earlier that the flip flop is a basic building block of the digital electronics or a basic building block of the digital electronic circuits, but some few of the basic applications are listed below. So, first, parallel storage data means a group of flip flop. In this case, a group of flip flops are connected together called a register. To store a data of n bits, n flip flops are required. So, in case of register, if we want to store n bits of data, then n flip flops are required. N bits means if we want to store 5 bits, then 5 flip flops are required. If we want to store 8 bit of data, then 8 flip flops are required. Since the data is available in parallel form, in this case the n bits or 5 bits, they are in parallel form. So, these bits may be available at the D input terminal of the flip flop, and when clock pulse is applied, these bits will transfer to the Q output of the flip flop. So, in this storage, D flip flops are used, means D flip flop has its applications in the storage devices, where T flip flop has its applications in the counters. So, parallel storage device is a storage application. So, D flip flops are used. Now, next, serial storage data. So, again it is a storage application. Storage application means where flip flop is used as a memory device. So, again here D flip flop is used, means to store a data of n bits available in serial form. N number of D flip flops are connected in cascading form. Cascading means one after the another. The clock signal is connected to all flip flops, means clock signal is connected separately to the all flip flops, and we can store the data serially. So, like this, the data is stored serially in all the flip flops. Means here the serial data is applied to the D input terminal of the first flip flop. Then each flip flop is connected in a cascaded form. So, with each clock pulse, the bits are transferred from its input to the output. Now, transfer of data means if you want to transfer the data from one place to other, from means input to output. Data stored in flip flops may be transferred in a serial fashion, means serially we can transfer the data from input to output bit by bit, means one bit at a time, or the data may be transferred out in parallel form. Parallel means all the bits are transferred at the same time. Now, counting, major application of flip flop is a counter, that is called counting, means a number of flip flops may be connected in a particular fashion to count the number of pulses electrically, means flip flops are used to count up, means to count upward or to count downward. So, in this case the T flip flops are used, because the T flip flop toggles means it changes its state with every clock pulse. So, the flip flop may be used for parallel to serial conversion and vice versa. This is also a application. So, this was all about the flip flops. So, here first we discuss what are the sequential circuits, then we discuss what are the types of flip flops, Then we discussed latch, means basic concept of flip flop. Then there was flip flops. In this flip flop, first we discussed SR latch, then gated SR latch means SR flip flop, then JK flip flops, then race around conditions, then master slave did JK flip flop to resolve the race around condition, and then lastly applications of flip flop. So, this was all about the flip flops. Thank you.